cosine now. So since we've learned about sine, we talked about the opposite side and the hypotenuse. And you saw a couple of times where you had to solve and find the other angle to be able to use that opposite side. Well, now you don't have to, because now with the cosine, if you're given the adjacent side and the hypotenuse, then you can find the that missing side length or the angle measure based on the cosine. So the cosine is the ratio of the adjacent side to the hypotenuse side. So basically, it makes up that angle that we're talking about. So if we're talking about theta here, it's the angle that's being made up by theta would be the adjacent side and the hypotenuse. So let's take a look here. So remember, we don't use that right angle. We're just going to use A and C. So if we're looking at the cosine of A, that's this angle right here. So the adjacent side is going to be this side right here, that's AB. So this is going to be the adjacent side. So the cosine of A is going to be the line, the segment AB, whatever that length is, divided by the hypotenuse, which is going to be AC, divided by AC. So that's going to be the ratio that's equal to the cosine of that angle. That's A. Then we'll look at angle C right here. So adjacent is no longer this side, that's opposite. Okay, so adjacent is right next to C. So adjacent means right next to or attached to. So this is the adjacent side, and then the hypotenuse stays the same. So cosine of C is going to be adjacent, which is BC, or you can call it CB, either one, divided by the hypotenuse, which is still AC. That still stays the same. Okay, and remember, we don't use B, that we don't use that right angle. So let's look here at this question number one. So we're going to find the value of X. So basically, now that you have another tool in your tool belt, so if you come across a screw that has a Phillips head, then you have to pull out the screwdriver that's a Phillips head. If you come across a screw that is a for the flathead, then you have to pull out the flathead screwdriver to be able to use it. So that's the same thing with sine and cosine. Like, what are you given, and then what tool do you pull out of your tool belt to be able to solve it? So therefore, let's look here at the cosine. So, or let's look to see what we're given. So we're given this angle here, and we're given the adjacent side, and we're given the hypotenuse. So that tells me I need to use the cosine, because the cosine is the adjacent side divided by the hypotenuse. So I'm going to say the cosine of theta is equal to the adjacent divided by the hypotenuse. So I'm just going to write that every single time, just so you're used to writing it and you'll be able to follow along with me. So I have the cosine of the angle we're talking about, which is 37, is equal to the adjacent side, which is what we don't know, that's x, divided by the hypotenuse, which is 14. So now to solve for x, that we have to get rid of everything that's with x. So to get rid of divided by 14, I'm going to multiply by 14 on each side. And so therefore, I'll just plug this into my calculator and find out what 14 times the cosine of 37 is. All right, so I'm going to make sure that I am in degrees over here, and I am. So then I'm going to type in 14 times the cosine of 37. And then I have 11. X is going to be equal to 11.2. So I'm just rounding to the nearest tenth, okay, just one decimal place, 11.2 there. So just to evaluate my answer, I'm going to look at the hypotenuse. It's supposed to be the longest side. The hypotenuse is 14, so x being 11.2 is a valid, at least a valid answer based on that, the fact that I know that the hypotenuse has to be the longest side. All right, so again, I'm going to look to see what I'm given to figure out what tool am I going to pull out of my tool belt to be able to solve for x in this problem here. So I have this angle here. I'm trying to find that angle right there. And then I'm given the 9 is this adjacent side and 20 is a hypotenuse. So which one's adjacent and hypotenuse? Oh, yeah, cosine. So I have the cosine of theta is going to be equal to the adjacent divided by the hypotenuse. All right. So I'm going to have the cosine of the x is equal to the adjacent, which is 9, divided by the hypotenuse, which is 20. Okay. So if you'll remember back from the last lesson, it's going to work out the exact same way. To undo this cosine that's with the x, I have to do the inverse of cosine. So I'm going to take the inverse of cosine, and that gets rid of this. Then I'm going to take the inverse of this cosine. And that actually has to come first. When you type it in, it's the cosine, then the inverse cosine, and then open parentheses and 9 over 20. So just kind of letting you know there. So x is going to be equal to the inverse cosine of 9 over 20. And then I can plug that in into my calculator. And I get 63. X is equal to 63.3. Now, since x is not a side length, I can't compare it to the hypotenuse, but I can compare this to the right angle. So remember that a triangle all adds up to be 180. Well, when I have a right triangle, I have 90 degrees already taken up by that right angle. So I know that the other two have to add up to 90 as well. So I need to make sure that my angle that it gives me is going to be less than 90 degrees, because that's all I have left if it's a triangle. Okay. So that's something that's kind of a little built-in check a little bit there. Also make sure it's positive. If it's a negative number, you may have your calculator in radians. So just double check that. Okay, so now this one is a little bit trickier, I guess, because there's two things I had to find: W and X. So I need to look here. So if I'm going to look at solving for W, okay, I'm going to see basically what am I given. Well, I have two triangles. I have a triangle here, and then I have a triangle on this side. Okay, so um, on this triangle right here, this one gives me, I actually have two variables. I have a variable in my angle and a variable in one of my sides. So I'm probably not going to use that one. Okay. I'm going to look at this triangle right here. This is my angle. If I'm looking for, and I'm looking at W, W is not adjacent. W is opposite. So this is kind of a refresher back onto sine. Okay, so opposite and then 5 is the hypotenuse. So that tool that you pull out of your tool belt is the sine. So the sine of 32 is equal to W divided by 5. Then, because sine is opposite over hypotenuse, I'm going to multiply by 5 on each side. I'm going to plug this in my calculator and see what I get. So it's really 2.65, and then that 5 makes the 6 round up to 7. So it's 2.7 is what we get for W. Now, okay, I'm going to have to go back now and solve for X. Well, in order to solve for X, I either need adjacent side or opposite side and the hypotenuse. So I have the hypotenuse, it's here. Okay. And so then W is actually again the opposite. Okay. And W is 2.7. So since I found W, I can now find X. So I'm going to have again sine, because I have the opposite. The sine of X is equal to the opposite, which is W. We found that out to be 2.7 divided by 6. And so what I'll do, remember, is I'm going to take the inverse sine of each side. All right, so X is going to be equal to the inverse sine of 2.7 divided by 6. And I'm going to plug this on my calculator, see what I get. And I'm going to get 26.7. So X is equal to 26.7. And since this is not talking about a side length, I can't compare it to the hypotenuse, but I can compare it to the 90-degree angle, and it is less than 90, so I can kind of sort of figure it out there. I mean, that's a little built in check. Okay, on the last one, I do want to go ahead and show you how to solve this using the cosine, because really, technically, the tool that you pull out is actually for sine because I have the opposite. But since we're supposed to be practicing cosine, that's what we're going to do here. So basically, I know that this angle is 38. So based on the fact that a triangle adds up to be 180, this angle here is going to be 52 because I have a right angle here. So that means that 38 plus 52 have to add up to be 90. And so then I have adjacent side here and the hypotenuse here. So cosine of theta, and I did not write this on the last one, is the adjacent over the hypotenuse. So the cosine of 52 is equal to x divided by 500. Then to get rid of divided by 500, I'm going to multiply by 500. And so then I'm going to plug this into my calculator, and I get 307.8. All right. So basically, I need to look at the hypotenuse. It's 500, and that has to be bigger than the side length I'm given, and that is good there. So I can kind of have a, like I said, there's a little built-in check there. So a couple of things. We did not solve for the hypotenuse on these examples, but you're still responsible for that. It still works out the same way as it did with sine, where you have to multiply by x and then divide by the sine. Well, this time it would be cosine there, and basically where x and the cosine are going to flip flop places. But flip flop is not a mathematical process. So when you're using these, remember that sine is the opposite over hypotenuse, and you can use that. Use it if you need to, if that's what you're given. And then cosine is going to be adjacent over hypotenuse. Again, use that if that's what you're given. Okay. So now it's your turn to practice cosine on your skill check.